Right, so we're just going to have a look at a small problem from one of the summatives. The question here states, use ln or log base e to solve the following equation, or to solve for x, really is what they said. Now, it's a weird question. It's one of those where they're just testing our ability to use our calculator, really, for lns and logs and so on. So what we're going to do is apply ln to both sides of the equation. We have ln x is therefore equal to ln. I'm going to put a bracket around this whole lot to start off. We'll show all the steps here. 0.45 multiplied by the root of 0.35. There we go. All divided by 0.12. And if I look here, I've actually left something out. That was squared. 0.12 squared multiplied by 1.5. And the idea is to show us apply the log laws where we take ln or log base e and we apply it into these calculations here. So continuing on, or to take the brackets away, what we have is the multiplications, or everything on top of our bracket, or on top of our line, sorry. We're going to leave that as positive. Everything underneath becomes negative. So we end up with a nice string of lns where we have ln of 0.45 plus, the multiplication becomes positive, ln of the root 0.35 minus everything underneath the line. We could subtract and then put in a bracket and say, well, that's going to be ln 0.12 squared, and then plus, because it's multiplied, ln 1.5, but of course that bracket's just going to work out with this negative here. That bracket's just going to work out negative, negative. So when we rewrite that, I'm going to rewrite it all ln 0.45 plus ln, still the square root. I'll simplify these shortly. 0.35, and I'm showing extra steps here. You don't have to show all of it like this, every single detail. This is just for the class. Then 0.212 squared minus, because now the negative multiplied into the positive here, is going to be a ln 1.5 still, but it's negative now. All right, now what do we do with all of these? Well, we simplify as far as possible. So we're going to leave this one. That's going to be ln 0.45 plus. Now here's the thing. There's almost like a little bit of side work that you can do. This square root is the same as saying that that is 0.35, and what I'll do is I'll move across here slightly and just show like a bit of rough work. So if we have the square root of 0.35, that's the same as saying 0.35 to the power of 1 over 2. That is that fractional exponent. So when we come back over here, we can rewrite this, of course, with the fractional exponent, 1 over 2. And the exponents go to the front. So I actually end up with 1 over 2 ln 0.35. So it's 1 over 2 multiplied by, because that exponent then just multiplies the entire log, minus, here the 2 does the same thing, 2 ln 0.212, minus, and this is just ln 1.5. And this is where we bring in the calculator. Again, it will depend on your calculator that you're using. I'll sort of make it not glary. But you'll see here I would use my ln function. Okay, mine is set up to an engineering setup at the moment. You might not have 0 point and all of that. That's fine. Whatever setup works for you. So I'm just going to use ln and really plug in those numbers, but I'm also going to multiply by the answers. So for our first one here, we're just going to put in ln 0.45 equals, and we're going to work to 3 decimal places here, just because of the, all of this could be done in one step. But I'm trying to show it in as much detail as possible. So we've got ln 0.45. It is 0 point, or it's actually negative, because we have any log that is less than 1 is going to give us a negative answer. So I'm saying negative 0.799, because I'm just rounding. That's going to be plus, and now it's going to be a half, because the half is still there. And we're going to say ln 0.35 equals, so it's a half, and I'm going to have to bracket it because it's a negative, and I get, where am I? 1.0499 I'm going to do a little more accuracy here. Instead of just saying 1.05, I'm going to add a little bit of detail in there. And then we're going to subtract, and we have 2, and it's multiplied by ln 0.012. So I just put in ln 0.12, and I get minus 2.12. That's good enough. And then minus, and it's ln 1.5. That gives me 0.406, in fact. From here we can simplify further, but again, this really could all have been done in one step to give us one answer. But I'm showing as much detail, exponent laws and such as possible. So I'm going to leave this with a minus 0.799. I'm going to multiply the half in, so it's going to be 0.5 times negative 1.0498. And that's going to give us a negative 0.525. Now I've got a negative multiplying into a negative. Over here, negative 2 multiplied by a negative 2.12. So it's negative 2 multiplied by negative 2.12, and I end up with a positive 4.24, and then subtract 0.406. Should all come to give us, let's make some room here, should all come to give us, let's see, it turns out that a lot of these end up negative, so that's how it is. And we're just adding them up, 0. And we get 2.529, I think. Let me double check. I think I left a decimal off. 0.25 plus 4.24 minus 0.406, 2.51 would be a bit more accurate. Let's just make that a 1. All right. Of course, we need to now remember that this is ln x, right? Not x. They've asked us to solve for x, so we've got to rewrite this as a log would work. And we know how a log is supposed to look, or how it is rewritten in the exponent form. If we had a log base, let's say bx equals y, for instance, we know that the y is the exponent, the b is the base, so we're looking at b y equals x. So we've got to rewrite this log in that form. So we end up with a base of e, because ln is log base e, to the power 2.51. It's a 1 that I made a mess of there. And that is going to equal x. All right, I've written it the wrong way around, but it'll work out at the end. All right, on our calculator, on my calculator anyway, second function ln will give me e to the power. It's 2.51 equals, and I get 12.305. That's our final answer there. Okay. Interestingly, let's see the textbook answer. Let's just double check. I do find that it actually varies from calculator to calculator sometimes. Let's double check our answer, 2.51, 305, yeah. So depending on how much rounding off you did, if you did a lot of rounding off during the question, kind of like I did, or if you keep everything together and get your answer at the end, you're going to end up with more or less accuracy. But these things are taken into account when marking as well.